Assalamualaikum and hi everyone. Now we start on chapter 5, functions and graph. Chapter 5 consists of 4 subtopics. For this lesson, we'll cover 5.1 functions. These are the learning outcome for this lesson. 5.1 Definition of function. A function is a set of ordered pairs in which no two ordered pairs that have the same first component have different second component. This means that any given x, there is only one y that can be paired with that x. One-to-one function. A function f from a to b is called one-to-one if whenever f of a equal to f of b, then a equal to b. No element of b is the image of more than one element in a. Example of this function. Okay, one-to-one function. So for every element in A, there is only one element in B that connected to A. 1 is the image of A, 2 is the image of B, and 4 is the image of C. Example for not one-to-one function. For element 2 in B, there is two elements in A that connected to B, A and C. So this is not a one-to-one function. Onto function. A function f from a to b is called onto if for all b in b there is an a in a such that f of a equal to b and all elements in b are used. Example of this function. Onto function. For every element in b there is one element in a that connected to it, and all elements in B are used. Example, function that is not onto. There is one element in B that not in use. The three inside B are not used. So this is not onto function. A function can be both one-to-one and onto. So for every element in B, there is element in A that connected to B. A to 1, B to 2, C to 3. And onto when all elements in B are used. Graph of a function. To test if a graph displayed is a function, we use vertical line test. Vertical line tests are drawn parallel to y-axis. The graph is a function if each vertical line drawn through the domain cuts the graph at only one point. Examples: graph of fx and vertical line test. Draw a vertical line parallel to y, and the vertical line only cuts the graph at one point, so fx is a function. Examples: consider the graph below and state whether they represent a function. Draw a vertical line test, and then the graph cuts at one point, so fx is a function. Example 2. For a graph to be a function, the vertical line test must cut at one point throughout the domain. Examples: if we put the vertical line test here, the graph only cuts at one point. But if we put the vertical line test more to the left, the line test cut at 2 points. So this is not a function. So for the fx to be a function, the whole domain must cut at one point. Since there one part of graph cuts at 2 points, so fx is not a function. And this is your exercise. Please submit exercises at the end of lecture.